Hello grade 9s, here's a video about acids and bases. So I know some of you are already at least a little bit familiar with acids, bases, and the pH scale. If not, here's some more to fill in the gaps and then also to connect it to environmental chemistry. So we're going to get a little bit into acid rain and then things that we can do to prevent it. So if you're ready, let's go! Hello grade 9s, I hope you're all doing well. Today we're going to do a little bit about acids versus bases. Usually people are more familiar with acids. We use them in regular life. There's things like vinegar and lemons. We do also use bases in regular life. They're normally for cleaning and things like that, so an example would be bleach. A second difference that you can probably already tell between acids and bases is that acids tend to taste quite sour, whereas bases tend to taste bitter. Another difference is actually how acids react with metals. When we put a piece of magnesium strip in hydrochloric acid, we notice that there's a lot of bubbling and the metal started to dissolve. This doesn't happen with bases. Another difference is how they react with litmus paper. Hopefully you've had a chance to use them before, but there's a red one and a blue one. If you put both of them into acids, they will both turn red. If you put the red and the blue litmus paper inside of bases, then they'll both turn blue. Now let's take a look at the pH scale. The pH scale is actually something that we use in order to measure how acidic or how basic a solution actually is. Another word for basic you might have noticed on here is alkaline. The middle of this table is 7. And so 7 means something is neutral. It's neither acidic nor basic. It shouldn't taste sour or bitter. It won't react with metals. It will turn red litmus red and blue litmus blue. Anything lower than 7 will be acidic. And so all the way from 0 to 6 on this table, but even 6.5, 6.9, all of that counts as acidic. The further you get from 7, the more acidic you are. So something that's at a 3 is not nearly as acidic as something that's at a 1. Once again, anything that's acidic will taste sour and will turn red and blue litmus paper red. On the other hand, anything that is higher than 7 on this table means it will be basic. And so it should taste bitter and it should turn both red and blue litmus paper blue. pH actually stands for the power of hydrogen. So it's actually the concentration of hydrogen inside of the solution that determines how acidic or how basic it is. If you think back to math, power actually means exponents. So if you take a look at vinegar, vinegar has a pH of 3. That means it actually has 10 to the power of -3 moles per liter of hydrogen. This means it has 0.001 moles per liter of hydrogen. On the other hand, stomach acid is at a pH of 1. And so that means it has 10 to the power of -1 moles per liter, which is 0.01 moles per liter. That's actually 100 times difference. With every single drop you make on the pH scale, you actually have a 10 times increase in terms of the acidity levels. And so 2 jumps is going to be 10 times 10, which is 100 times bigger. Now let's take a look at the environmental chemistry side. So the biggest issue we have with acids and bases is probably the acidic rain that comes from the sky. The 2 biggest causes that we have are cars and factories. And if you think back to combustion reactions, both of them will burn their fuel, which causes it to combine with oxygen and turn into a gas. In the case of cars, the nitrogen inside the fuel will combine with the oxygen to create nitrogen oxides. In the case of factory, the sulfur inside of the coal combines with the oxygen to create sulfur oxides. The X after the oxygen just means it's a variable, so it could be 1, 2, or 3 oxygens mixed with each sulfur. The nitrous oxides and the sulfur oxides will now travel up, and then they will go into the clouds where they combine with the water to create acids. This will then come back down onto the earth in the form of acid rain. On this slide you can see another drawing, so you can see that there's the factories and then the acid gases are going up into the clouds, so the sulfur dioxides and the nitrogen oxides, and then the gases are carried by the wind into the clouds where they dissolve in the rainwater to form acid rain and come back down. So the problem with acid rain is that it will kill the plant life, pollute rivers and streams, and erode stonework. So here on this side you can see the critical pH levels for aquatic organisms. A lot of them tend to not do well as soon as the pH level drops. A lot of organisms like the fish will probably not die immediately from the acid rain, but it will affect the fish eggs, and so they won't be able to reproduce, which will cause their population levels to drop. And then down here you can see another example of environmental effects. So normally, clean rain and healthy lake water is about 5.6 to 6.5, so it is actually slightly acidic on the pH scale. But acidic rain is once you hit that 4.2 to 4.4 area, an acidic lake is about 4.5. So as you drop in pH, it does become dangerous. And even around 6, rainbow trout will begin to die. At 5.5, a lot of the frog eggs, tadpoles, crayfish, and mayflies die. And then at 4.2, all the fish start to die. Not only is there an environmental effect, there's also a huge economic effect of acid rain. So, for example, our bridges are made with metal, and if you remember, acid tends to react with metals and to degrade it. So that means a lot of our bridges and our buildings need to be replaced over time. A lot of statues that are made from stone are also dissolving in the rain as well, and so great artwork has been destroyed during this time as well. One of the solutions that we have is limestone. So limestone is actually naturally basic. What we can do is actually take the limestone, and then what we do is lime the lakes. So if you have an acidic lake like this, you can actually spray a bunch of limestone all over the lake. This is not really dangerous for the lake because limestone is naturally found in nature, but it's not a permanent solution because as soon as it has more acid rain, it'll use up the limestone and then you're stuck with an acidic lake all over again. Some lakes naturally have a limestone bed, and so they'll be a lot more resistant to acid rain than other lakes. But let's talk about actually preventing the acid rain from occurring in the first place. We said the two worst offenders are cars and factories, and so what we have are catalytic converters inside of the cars, and we have scrubbers inside the factories. Let's take a look at catalytic converters first. So if you remember, a major issue in cars is actually the nitrogen oxides, and that will create acid rain later on. Another problem with our cars is actually just carbon monoxide. So if you remember from chemistry, carbon monoxide is very similar to carbon dioxide, but it will kill you. And so neither of those things do we want going out into the atmosphere. And so when both of them come through this catalytic converter, there's a reaction. And then one of the things that happens is the carbon monoxide and the nitrogen oxides will form carbon dioxide and pure nitrogen. This is actually what gets released into the air later, and nitrogen is actually going to be naturally found in the atmosphere. Carbon dioxide can be used by plants later, and so it's a little bit better than the carbon monoxide and the nitrogen oxides. For scrubbers, this is found in factories, and so naturally there's a bunch of sulfur inside of the coals, and so what they do is same thing, they're going to take the gas containing a lot of sulfur oxides, and it goes through all these scrubbing slurries. And then what happens is it causes the sulfur to go to the bottom, and so all the air without the sulfur is going to release out the top of the smokestacks, and then all the sulfur will travel down and then go into the sludge removal system. Alright, so that's it for acids and bases. Just a quick recap. We took a look at the difference between acids and bases, and then we took a look at our pH scales, and then we continued on to take a look at how acid rain is formed and our two main culprits, so cars and smokestacks, and then the effects of acid rain as well as how to prevent it. So hopefully that was a good breakdown and an intro into acids and bases. If you have any questions, make sure you reach out to Mr. Robbins, Mrs. Richards, or to myself. Have a great week. Bye, grade 9s.